We're dealing with sequences, this first worksheet on diverging and converging. I'm going to try to go quickly through this information. We were given that -4, 1, and 6 were the first three entries of that. If I start taking any term and subtracting the previous term, I find out rather quickly that the common difference between the terms is 5. Okay? With the common difference between the terms being 5, I can go ahead and decide that it's arithmetic and I need the explicit formula. I know the first term is -4. I know the common difference between the terms is 5. This is the explicit formula, which will come in very handy. We are going to generate some terms and look at a graph here quickly. Let's see if I can. So get into your calculator. We are going to get into the lists. Clear out everything in your lists. Go to the very top of the list. Since if I go too fast for you, just make sure you pause, back up, copy things down that you need. So I'm going to run through a very simple, instead of entering the numbers 1 through 150, I'm just going to do this one time with sequences, or a sequence generating function. Right above the stat button is list, so second, list. And we can go over to operations, or ops. Okay, the fifth one in the list is sequence, and so we want that one. Okay, please make note that you're at the top, you're not in the first entry of the list. You might want to just follow this instruction. The very first entry, sorry, I don't want to point with that finger. The very first entry in the list is an x. That represents the function that we're dealing with, y equals x. And then we are telling it what variable we're using, and then what starting point we're using, and what stopping point we're using. So the first one represents the function that you're using. The second one represents the variable that you're using, and then your starting point and stopping point. Okay, when you let it do that, it will enter the numbers from 1 to 150 to prove it to you. I will go to the bottom of the list by using the up arrow, and that'll get me from one end to the other rather quickly. Okay, we're going to go to the second list. In fact, I'll use that sequence formula. I'll show you two different ways we could have done that. We could do the sequence formula again. Okay, sequence. This time, the expression is right there, -4 plus 5, parenthesis, x minus 1, end parenthesis, comma. Then you tell it what variable you're using, x, comma. Then you tell it what starting value, 1, comma, 150 is the ending point. Okay? So it will enter all those values. Now that is one way to do it. We could have also done it, and this probably is a lot easier, but I did want you to see how the sequence formula generator is kind of nice. But we could use this, -4 plus 5. Now instead of using x, we're going to use, like we've commonly done in the past, a list 1 minus 1, right? Well, we're putting all of our x values are in list 1, so we're using those. And you're not going to notice a difference because it's the exact same set of numbers. Okay, I want to show you the graph. Well, first of all, I want you to kind of look at the bottom of the screen. You can see the actual number, maybe in a little bit larger print. I'm just going to hold this button, and as it continues down to the bottom at 150, you can take a look. Now, remember that converging means that the sequence has to get closer to one single number. It can't be getting closer to, it can't be getting further away. It can't be jumping back and forth. It has to be getting closer to one single number. But as you notice, it doesn't look like this thing's slowing down at all. You're getting all the way to the end, which is 741 is the 150th term. Doesn't look like it's slowing down. There is no limit. Let's take a look at the graph. Remember, a scatter plot is above a y equals, or stat plot, and then make sure one of them is selected to the on position, and scatter plot with the dots. And I'm actually choosing the dot so that it's easier to see because there's going to be a lot of them. When you go to zoom 9, you're going to see what looks like a straight solid line. I'm going to use the zoom in feature because I want to show you something. This is not a solid line. And now you can see the cursor blinking in the middle of the screen, so I'm going to hit enter. It's going to zoom in, and you're going to start to see that the points are not really connected at all. There's space in between. I'll hit the enter button again. You can see now that there's lots of space in between. That's because the values we're putting in are like 1, 2, 3, 4, 5. Because we are looking for the first term, second term, third term, fourth term, fifth term. There is no 1.375th term. Okay? Yes, I made that up. But there's no terms in between, right? So that's why there's all this space in between the points. Because we're just looking at the sequences. But when I look back at this, I know we stopped at 150 terms. It would keep going. So there is no limit. And if I think that there's no limit, Part B says, determine if it converges or diverges. It diverges. Okay? And for those of you who don't know what that means there is no limit. Okay? It's not getting closer and closer to anything. So the word diverges means no limit. Please don't get to a quiz or test and think diverges and then you tell me some number. Because then I know you don't understand what diverges means. If you think it converges, then you tell me what. And Part C says, if it converges, give the sequence's limit. So obviously, I'm not going to put anything on line C because I believe it diverges. I know it diverges. Okay, next one on my list. Okay, this looks like a recursive formula for geometric. Now, if you're unsure, write out the first three terms. Multiply by 1.5. Multiply by 1.5. Okay, now, I know it's multiplication by 1.5. That is the geometric way. And so, what do we have here? First term times common multiplier. Now, if you're unsure about the common multiplier, the ratio, take any term and divide by its previous term. Any term and divide by its previous term. But it should make sense because it was a recursive formula to begin with. Okay, you were multiplying by 1.5. Okay, now, if I go into, I think I'm going to clear out my list and only use about 30 numbers instead of 150. If we have the explicit formula, we should be able to calculate the 150th term. Oh, by the way, that's going to be a really big number. So if I go back here, just do that. I want to see if you can even find it. We'll see. Okay. 150 minus 1, I'm sure everybody knows it's 149. Oh, it does calculate. I didn't know if it would be overflow error. Okay, so that 150th term would be the 3.46 times 10 to the 26th power. Okay, rather big number. When you want to graph this, that's why when I get back into my lists, I'm going to get rid of that first one, and I'm going to get rid of this one. I'm only going to use the first 30 numbers. So second stat, ops, sequence, okay, y equals x, comma, variable, comma, 1, comma, 30. Okay, let it use those values, 1 through 30. And now I can use this, 2 times 1.5 caret, and use parentheses around the exponent. List 1 minus 1. Okay? Take a look at the graph, and if we do a zoom 9, why don't I have to go back and set up the scatter plot again? Because it already is set on list 1 and list 2. However, I am going to go change the symbol to be the square so it's easier to see. Now if I go back to my graph, you can see that it's really low, really low, really low, really low, and then it takes off. Okay? So it's exponential growth. That does not look like it's stopping. It does not look like it's getting closer and closer and closer to anything. So, once again, this is another one of those. So you can copy down. We've got the first three terms there. You can either go into the lists and find the next, there's the first 7 terms. And you can see them down there at the bottom of the screen. The bottom of the screen shows you the better numbers. Or the more accurate numbers, I guess. You can round to the tenths or hundredths, probably the hundredths place for accuracy on what we're doing. And it is also a divergent. Okay. So there's no limit. Okay, let's look at 3. We're gonna speed things up as we go here. This is called a rational function, and so let's get back into our lists and see what's going on. I'm going to clear that out, and I'm going to use parentheses. We've got 3x squared minus 5x plus 3 in parentheses divided by, oops, why am I using x's? Somebody stop me. My goodness, it's ridiculous. Okay, 4 list 1 squared plus 7 times list 1 minus 2. Okay, in parentheses. Let's take a look at those particular values and see what's going on. It looks like they continue to get bigger, but is it slowing down? That's the question. I'm not sure. Maybe I do need to go to 150. Let's just do that. Let's just do the sequence. Oh man, that's going to take forever to type that thing in. Oh. Let's go over here and we'll do second step ops sequence x comma 1 comma 150. Didn't think I needed to go to 150, but plus you can also plug in 150 into this equation to find the 150th term. But we're gonna do it like we did before. So let's see. 3 list 1 squared minus 5 list 1 plus 3 in parentheses divided by 4 list 1 squared plus 7 list 1 minus 2. I promise you there are easier ways to handle these things. I'm just trying to show you, I'm just trying to make the connection between limits, and once we get into the limits, I've got much better ways of handling some of these issues. Okay, so take a look at the values as I continue down the chart. It looks like it is growing, but it doesn't look like I'm trying to make a decision on whether I think it's slowing down. Do I think it's slowing down, or is it just continuing to get bigger and bigger and bigger and bigger? Okay. It does. It looks like it's starting to slow down. It is still increasing, but it looks like it's getting to the point where it's starting to slow down. There's your 150th term there at the bottom of the screen, and obviously you can approximate that. Maybe the thousandths would be good. So let's see here. Let's take a look at the graph of that. Zoom 9. Oops. Zoom 9. Okay, now in this particular picture, it is showing me that it's approaching a horizontal asymptote. And that's the whole idea of a limit, is it's getting closer and closer to a particular asymptote. Now the big question is, what is it getting closer and closer and closer to? Well, if you would extend that out farther and farther and farther, what you would see is something that I'm going to really show to you later, but might as well show you now. Take the largest power. Here, I'll zoom in so you can see what I'm doing. Nope, not that one. There we go. Take the largest power of x in the denominator. That happens to be x squared. Really what you're doing is you're multiplying the top and bottom by 1 over x squared. Now I'll show you. This is painful algebra maybe for some of you, but once you understand it, it will get a lot easier. Okay, so 3x squared times 1 over x squared is just plain old 3. Right, because the x squared terms cancel. And negative 5x divided by x squared, that is negative 5 over x. And 3 over x squared. And then on the bottom, you got the 4x squared divided by x squared. Okay, so that's a 4. And 7 over x, right? Because when you get rid of one of the x's, that gives you just 7 over x, and minus 2 over x squared. Now, let's understand what's going on. X is getting bigger and bigger and bigger and bigger and bigger. Well, what happens to this when x gets bigger and bigger and bigger? Negative 5 divided by a million, negative 5 divided by a billion, negative 5 divided by a trillion. That's getting smaller and smaller and smaller. In fact, we say that this disappears to 0. That's because it's based on the harmonic sequence we talked about earlier. This is even worse. It's going to 0 faster because the bottom's getting larger quicker. This is going to 0, this is going to 0. So we got a lot of stuff that just disappeared in a heartbeat because x is getting so big. But what's staying is 3 divided by 4. Now, go back to the picture, go back to the table, the 150th value. Do you see that we're getting closer and closer to 0.75? If we kept going and going and going, we would be getting closer and closer to that value. And on the graph, that's exactly what's going on. In fact, if I put y equals 0.75 on the graph, you would see that that is the horizontal asymptote we're getting closer and closer to. Do not be deceived and think that those squares are touching the line, because it can't. It's an asymptote. Remember that? Okay. Question 4. We're talking about, well, hopefully you're understanding that we're multiplying by 1/2, right? It's multiplication by 1/2. So this is geometric, and I'm so used to using G's for geometric and A's for arithmetic, but you use what you want. If you want to use all A's, that's fine with me. First term times 1/2 to the n minus 1. Now, realize something. These are like exponential growth and decay. So this was an exponential growth. And what happens to exponential growth? It never stops getting bigger. The growth factor is larger than 1. Well, what happens to exponential decay? It keeps getting smaller, right? So this is going to continue down and down and down and down and down, cutting in half all the time. Never getting to what? Well, maybe I could put that in really quickly. Stat, enter, just take a look at these values. Clear. Okay, so 40.5, oops, sorry, caret, L1 minus 1. Alright, so just take a look at the values. Someday, okay, sorry, I got paused for some reason. Okay, and as you continue down, you'll see that it's getting smaller, but it's, oh, now wait a second. At first, if you look at the bottom, you think it's getting bigger, but it's not. Remember, these are exponents, right? 10 times 10 to the negative 4th times 10 to the negative 5th times 10 to the negative 6th. So we're actually getting super duper small and getting closer and closer and closer to 0, right? That has everything to do with what we've talked about millions and millions of times before, the asymptote for an exponential decay function. So question 3 was a converge. And what did it converge to? It obviously converged to 3/4. But when we got down here to question 4, it was also a converge, and it converged to 0. Okay. By the way, make sure you go back and find the 8th term, including the 150th term. So plug 150 in, find out what you get. Okay. And you plug in 150. Okay, next 4 questions. Going to try to go a little bit faster so we can get this done. Now that you have the general idea. Okay, largest power of n in the top and the bottom. This is another one of those where you can take a look at the graph, find the points, see what's going on with the picture. See if I can do this quickly. Whew, man. Evidently not. I should have done that a different way. Okay, clear down arrow. Let's see. 8 list 1 squared plus 4 divided by 5 list 1 to 3rd minus 8. Okay. And it'll spit out the values here soon, and we can go zoom 9, take a look at the picture. And it looks like it's getting closer and closer. And why is there a line in the graph? Because I left it there accidentally. So let me get rid of that line and go to my graph. Why is there like a random point down there? I don't know what that's for. Okay, but it's getting closer and closer and closer to 0. Take a look at it when you divide everything top and bottom. Was I even on screen? I hope I was. When you divide everything top and bottom by n cubed, and you go through here and you divide that, that becomes 8 over n, right? So 1 over n cubed, 1 over n cubed, top and bottom. We would get 8 over n we would get 4 over n cubed. Obviously, both of those things are going to be disappearing to 0 pretty doggone quickly. We get 5 and minus 8 over n cubed. That's going to disappear to 0. So we're left with 0 over 5. We know that's going to be 0. So we are converging, and we're converging to 0. And you can go back in your lists and find the first 8 terms using what we talked about. Okay, so on these next ones, I'm not going to go through and find the first 8 terms. You can do that on your own. Okay, so because I'm just trying to speed up the video for you. All you're doing is plugging in 1 through 8, and you can use the lists for that. This is obviously exponential decay. So since that's happening, understand what the picture is going to look like. The picture we draw is going to look something like this. So hopefully everybody's saying, oh, that's going to converge to 0. Okay, this one looks like it's going down by 8, right? So that's constant difference -8. That's arithmetic. And I'm hoping by this time of your life you understand that arithmetic means a linear function. So if you take a look at first term plus constant difference, which is -8, I guess I didn't need the plus, but times n minus 1, with it being a linear function, it's going to keep going down, 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 and it will never stop. So this is one of those diverging sequence. Now, large power of n in the top, or in the bottom there, is n squared. Okay, when you go through and divide everything by that, so 1 over n squared, 1 over n squared. What we're ended up doing is we get 10n. Why is there x's and n's in the same problem? That's really confusing. Okay, so we'll change this to an n, and we'll change this to an n. Okay, so this ends up being 4 over n. We know that's going to be one of those things that disappears to 0, right? Because n's getting super huge. Well, on the bottom we got a 5 and minus 8 over n. Once again, that thing's going to disappear to 0. But I want you to notice something in the top. We've got 10n in the top. N's getting super big. This is unstoppable. You can't stop this one. So this one is definitely a diverging. There is no limit to this one. Because with the power, with n being in the numerator like that, I mean, take 10 times a million and divide by 5. 10 times a billion divided by 5. 10 times a trillion divided by 5. It's just not going to stop. Okay? So that's the basics of this. If you want to find those first 8 terms and the 150th, always just plug in the numbers that you need. 1 through 8 and 150. Don't forget to plug in 150. Okay? And make sure you get those values taken, figured out on that particular, on those last 5, since I kind of went through that quickly. Thanks.